PLP, I can't talk. Those are considered the 3 undefined terms of geometry. Point, line, plane. Those are the building blocks for all the other terms in geometry. What's a point? What's a point? A location in space. It has no size, it has no thickness. It is a location in space, and how do we name it? How do we name it? With a capital letter. Okay, when we take a series of points and we line them up, what is that called?
A line.
It creates a line. If it goes on forever in 2 directions, it creates a line. So a line is not just a line, it's a series of points. How many points?
2.
An infinite number of points. How do we name a line? With 2 points. Very good. I wanted to give you something there. Okay. So we name a line with 2 capital letters with a line symbol on top. Very good. Okay. Yes, please, Ethan. Now, if we take that line, now we started at point, and with those points I created a line. Now we've got a line, and let's say I chop. Then we need a segment. A segment is a portion of a line. By definition, a segment is a portion of a line. It has a beginning and an end. How many points does a segment contain?
2.
It still contains an infinite number of points. Because remember, from A to B, how many points are there? 1, 2, 3, 4, 5. Oh no, I'd be counting for the rest of my life and beyond. There's an infinite number of points, even in a segment. Yes, ma'am. Sure, go for it. Okay, if we take that line that we had a few edits ago, if we take that line, it doesn't want to do, there we go, and we only cut off one side of it, what do we have? Array. Array is sometimes called a half line. If you see that on the test, that's what array is, a half line. It still contains an infinite number of points. Does the order matter when you name array?
Yes.
Yes. So there's a problem, for example, on your review sheet, or maybe I'm thinking of the test where it says, are these the same set of points? No, because you cannot change the order when you name array. The order matters. These are not the same set of points. Now, if I did that with a line symbol, are these the same set of points?
Yes.
Absolutely. So the only time that order matters is when you're naming array. Okay, so that's me going over kind of the first 3 words or so on the vocab. Now I want to go over the 4 basic postulates, because we can answer so many of the always, sometimes never questions that everyone hates. We can answer a lot of those with the 4 postulates. You don't need to write these down because you have them somewhere in your notes. You have them. You took notes on it. Okay. One of the postulates says, if 2 lines intersect, they intersect in exactly 1 point. Very good. So if 2 lines intersect, they intersect in exactly 1 point. So the intersection of 2 lines is a point. Then we did the same thing, but we did it 2D instead of 1D. If 2 planes intersect, they intersect in exactly 1 line. So when 2 planes intersect, you get a line. So that was kind of our second one. Let's see if I can draw one. Pretend like he's coming out there. Okay, so the line is the intersection. Okay, so there's 2 of our postulates. The next postulate talks about how many points it takes to define a line. How many points does it take to make a unique line? How many points does it take to make a unique line?
2.
2. It takes 2. So through any 2 points, there is exactly 1 line. Through any 2 points, there's exactly 1 line. And then the last postulate, the one I think we have the most trouble with, I nickname it the tripod postulate. But this one says, through any 3, what kind of points? Any 3 non-collinear points, there is exactly 1 plane. Let me explain that better. Through any 3, I'm just going to write it, through any 3 non-collinear points, there's exactly 1 plane. So I described it to my students as the tripod. I use it probably way too many times, the same example over and over. But to me it makes sense. So when you set your tripod up to take a picture, the legs are nice and spread out so that all the feet of the tripod are touching the ground. It's stable. You snap a picture. But if for some reason those legs of the tripod were pushed in a row, what would happen to the tripod? It would fall over, and you wouldn't be defining a plane. There wouldn't be just one plane. There would be an infinite number of planes. So if you want to define a plane, you need three, what? Three or more what? Non-collinear points. You need three or more non-collinear points if you want to make a plane, define a plane, create a plane, form a plane, all of that good stuff. Okay, the last lesson that we only learned 3 lessons, guys. This test is only over 3 lessons.
Thank you.
So it's over vocab, it's over the postulates, and then it's over logic and reasoning. And that's the one where you just got a quiz back from it today. You had your conditional, then you had your converse, then you had your inverse, and then you had your contrapositive. So you need to memorize what those mean before tomorrow, because on the test you can't use notes or a homework assignment. You need to just use whatever is stored in your brain. So that was our last lesson. Knowing what the test covers now, let's go over questions you have from the review sheet, and then if you want to get an old quiz out or you want to get a homework out and ask me questions from those, you can do that as well. All right, yes, sir. No, I've got a whole class full. Give me a problem. Give me a problem. All right. Great problem. One that I definitely didn't talk about in class unless someone asked about it, and one that's a little bit hard to visualize unless you have something in front of you. One of the postulates talks about 2 planes. 2 planes intersect in exactly one line. But there's no postulate about 3 planes, so we kind of have to really try to visualize this. What I was telling one of my classes today was, okay, 3 planes. Okay, what could be planes? Okay, the ceiling and the wall and the floor of the room, those are all planes. That's a good place to start. So let's take the ceiling, let's take this front wall, and let's take the left wall. Where does the ceiling meet the front wall, meet the left wall? In that corner. So you're watching the video. In that corner. A corner. Is a corner a point, a line, a plane, a segment? What's a corner? You said it. You're right. It's a point. Yes. I just messed up my camera. A corner is a point. So 3 planes can intersect in exactly one point. That is true. Let me give you another example. If we had our prism that we always draw. Okay, where does the green intersect the red, intersect the purple? Now, if I took 2 planes at a time, the purple and the green, you get a whole line. If I take the green and the red, you get a whole line. But if I said, where do all 3 of them meet? Where do all 3 of them meet? Do you see it? All 3 of them, this is the only place that they all 3 had in common. So 3 planes can intersect in exactly one point. True. True. Almost all of these questions can be answered by drawing yourself a little prism and kind of thinking it out with that 3D prism. You need something 3D. Something 2D is not going to cut it.
So
yes.
Would be false, right?
Okay, so 31. Just having to fix that. 31. Very good. If 2 planes intersect, they intersect in exactly one line. They can't intersect in a point. Good. 31 is false. Okay, what else? Yes. 36. When a set of problems say, give me a counterexample, that means that those sentences are already false. They are false, and you need to show me how they're false. You can write, a word, you can write a number, or you can draw a picture. This is one where you would want to draw a picture. So on the test, if you're given a problem like this, you need to start sketching pictures. Your first picture might not be the right answer. Let me show you an example. Here's a picture. Here's ray AB, and here's ray AC. Unfortunately, that picture is doing exactly what the sentence told me to do. A, B, and AC are intersecting at point A. So that one is not a winner. It's not a counterexample. So I walk over there and get one of Miss Stanton's big erasers, and I erase it, and I try again. What do you want to try next? Oh, wait, this is already false. We have to draw a picture to prove it wrong. Our first picture was not a good one. We're going to try again. Okay, two rays going in opposite directions. These are called opposite rays. A, B, and A, C. Where does A, B intersect A, C? Oh, no. We made it true again. Scratch, erase. That's not a good example. That's not a counterexample. Okay, good. So our counterexample is going to have to be one where they're overlapping. So ray A, B, start at A, go through B, continue forever. And ray AC, start at ray, go through C, continue forever. Actually, those are the same ray. Those overlap in the entire ray. I proved it wrong. I found a time where I've got ray AB and ray AC, and they don't intersect in point A. I proved it wrong. That's called a counterexample. So this picture is your answer. You don't have to explain it. You don't have to use words. The picture is your counterexample. Okay. Plus 20, sorry, what? 22 and 3. Okay. Okay, 22 is literally one of the 4 postulates. You've only got 4 of them. You need to know them, memorize them, understand them. 2 points determine a plane. So one of the postulates says through any 2 points there is exactly 1 line. So that doesn't work. And then another one of the postulates says that 3 non-collinear points determine a plane. So if you need 3 non-collinear points, would 2 points cut it? No, 2 points wouldn't cut it. So that's false. 2 points is just simply not enough to determine a plane. Now, if I said 2 points are coplanar, that's true. 2 points are coplanar, but that's not the same as determining a plane. So if it says determine, make a unique plane, that's false. 23. A line and a point not on the line determine one plane. Okay. So, where's my skewers? Here's my skewers. Okay. How many points does it take to make this line? I have a skewer, it's my line. How many points? 2. It has an infinite number, but it takes 2 points to make this line. So I have 2 unique points here. Okay? So I've got a line, and then I've got a point not on the line. So I've got a point up here. Now, how many unique points have I collected? 2 from here, and then 1 here. I have 3 unique points. Are they collinear? Well, if it says that last one has to be not on the line, they're not collinear. So I have 3 non-collinear points. Does that determine a plane? Yes. 3 non-collinear points. Yes. So the line gave me 2. There's 2 points. The point gave me 1. 2 plus 1 equals 3. I'm not trying to insult your intelligence. I'm just showing you how you could reason this out. I've got 3 points. Yes, 3 points determine the plane if they're non-collinear. Okay, give me another one. Yes? 13. Lucky number. This one, quite honestly, we probably should have taken off the review. We're going to cover perpendicular a lot more in a different unit. We haven't said that word very much in this unit, not as much as I thought we would have. So you don't need to focus on that too much. Perpendicular is 2 lines that intersect at a right angle. We've been assuming throughout the entire unit, we've been assuming that these pictures are always prisms. In a prism, every corner is a right angle. It's not the Leaning Tower of Pisa. There's no obtuse angles. Every angle is a right angle. So, do these 2 segments intersect at a right angle? The answer is true, but don't worry about it. We're not going to cover that on the test, okay? You do need to know that they intersect, though. They're not parallel and they're not skewed. Just make sure you know that. Okay, give me another one. 30. 30. If points A, B, C, and D are non-coplanar, then no one plane contains all 4 of them. So this is a matter of knowing your vocab. You need to study your vocab, understand your vocab, know your vocab. There's a Quizlet on the calendar. It's on the calendar, and you can review yourself and test yourself over these words. Non-coplanar means they are not in the same plane. No one plane contains them. So I really can't explain this very much other than you need to know what this word means. It means they are not in the same plane. I cannot draw a plane that contains all 4 of them. I can't. Since I can't draw a plane, then this is a true statement. This is saying all the right things. That one's true. Yes? Number 2. Okay. You're so welcome. When I started this tutoring session, I started with a collection of points, and I called it a line. And then I said, if you cut off the arrows, you get a segment. And then I said, if you only cut off one of the arrows, you get a ray. So think of everything starting as a line. Everything starting as a line. Line goes on forever in how many directions? Both or 2. Good. Goes on forever in 2 directions. What does a ray do? Goes on forever in 1 direction. This is saying a ray is part of a segment. Where does a segment go on forever? Nowhere. No, a segment has a beginning and an end. So that's saying a ray is part of a segment. That's false. A ray is part of a line, but a ray isn't part of a segment. It's the other way around. A segment is part of a ray. Because a ray goes on forever, so it can't be part of something that has a beginning and an end, a start and a stop. So number 2 is false. Something that goes on forever can't be part of something that has a beginning and an end. Alrighty, let's keep going. Yes. 18. 18. Hi.
You have a class right now, huh?
I have tutoring for the test tomorrow, yes. Yes. I'm going to pause my video. 18. The intersection of a line and a plane may be the line itself. I think I went over this a lot in my classes, so sorry if you're hearing this again. When you don't know how to answer a question tomorrow, you need to brainstorm all the possibilities. Maybe not put a skewer to your head like this. Okay, so you've got a plane and you've got a line. You've got a plane and you've got a line. Let's brainstorm all the possibilities. So what if I did this? This plane and this line. Where do they intersect?
Never.
Never. Very good. Parallel. So the intersection of this line and this plane is nada, nothing, doesn't exist. Okay? That's scenario A. Now here's scenario B. What's the intersection of the plane and the line? It is a point. The line is passing through the plane. Where do they intersect? Right there. That's a point. That's a dot. That's a location in space. So scenario B, they intersect in a point. Point. Okay, scenario C. Here we go. Scenario C. Where does the plane intersect the line? The entire line. Intersect means overlap. Where do they overlap? What do they have in common? Well, they have in common this entire series of points, this entire line. So the intersection of a line and a plane may be the line itself. That was our scenario C. We found a time when it's true, so we're going to say true because it didn't say it's always the line itself. It said it may be the line itself. Okay. Did that make sense?
Yes.
Okay. I like enthusiastic, loud answers.
I just want to make sure you do.
Uh-huh. All right. Let's see. 8. Okay. So if this said, because by the way, this will probably be on the test tomorrow.
Oh.
If this said A, B, and C are coplanar, what do you write?
On the same plane.
Oh, true. Yes, sorry. Points. If it says points A, B, and C are coplanar, you put true or you put always. You don't need a picture. Any 3 points are coplanar. But that's not what this one says, so I just want to make sure we understand the difference. This is talking about 4 points, not just 3 points. If it's 4 points, you need to consult the diagram. Sometimes it'll be true and sometimes it'll be false. So I need to look at my diagram. So you've got A, B, C, and H. Here's a strategy I recommend. Look at 3 of them at a time. Just look at 3 of them. find the plane that they're in, because they're going to be in a plane together, and then find out if the fourth one is in that plane with them or not. Did the fourth one get invited to the party or not? So A, B, and C are all in this top of the prism plane, and unfortunately F is left out. Wasn't invited to sit at lunch with them. Not invited to the party. Sorry, H, you're left out. So the fact that they're coplanar is false, because H is not in the same plane that's defined by A, B, C. A, B, and C defined a plane. It was set, and he wasn't in it. What else? Or she. Or it. Yes, you don't have to ask permission. You don't have to apologize.
Oh, I'm sorry.
Yes. Yeah, make me sound like I'm such a big teacher or something. Which one? 3. 3 is one that I probably didn't enforce enough in class. If you don't put a symbol above it, you don't put a segment, you don't put a line, you don't put an array, if you leave it empty, then it is not a segment, it's not a line, it's not an array, it's a number. So if you leave it empty, here's K, here's M. KM, like this, KM is the distance from K to M, like 6 feet. So it does represent the length of a segment. So if I didn't go over that enough, there I am, I'm going over it. So KM right here is a number. It is not an object. It's not a segment. It's the length of the segment. Okay. That's what happens when you leave it without notation. It's a number and not an object anymore. All right, give me some more problems. Which one? 14.
And then 37.
Sure. True or false, plane A, E, F. Now, realize on a prism, when I name 3 letters, there's really a 4th letter that can be named, and you need to find that 4th letter, because sometimes it's shooting through the prism, so you need to find the 4th one. What other letter is coplanar with A, E, F? Good, B. I found it, now I'm secure. This plane does not have edges, but I'm representing it with that right there. Now, H, G, B. H, G, B. What's the 4th point in that plane? F. Very good. So the red and the blue. Are they parallel? No. Why not? What's the problem?
They intersect.
They touch, they intersect, they cross, so false. Okay, I'm sorry, I heard it was on the back, but I forgot which one. 37. Okay. We already did 36. Okay. Ooh, yep, there's going to be a problem like this on there. 37. The difference, okay, what does difference mean?
Subtract.
Subtract. What does product mean? Multiply. What does sum mean? What does quotient mean? Divide. These are all words that you got in previous math classes. Okay. The difference of 2 negative numbers is a negative number. So we want the beginning of the sentence to be true, and we want the end of the sentence to be false. We want to crash that sentence's hopes and dreams. We just prove it wrong. Yes. You have an example?
Yes.
I'm ready.
-1 minus -1.
Let's try it. Let's try it. What is -1 minus -1? The negatives cancel. -1 plus 1
0.
is 0. Is 0 a negative number? No. We proved it wrong. Very good example, Cole. 0 is neither positive nor negative, so that works. There are lots of counterexamples. This one has many, many, many answers. So there's lots of counterexamples there. Alrighty. You have to memorize these words. By tomorrow you have to know what a converse is, what an inverse is, what a contrapositive is. Let's go over them real quick. I'm not going to use P's and Q's because a lot of students actually really don't like those. I'll use H and C. What are those standing for? What do H and C stand for? Hypothesis and conclusion. All right. So the original is if H then C. If hypothesis then conclusion. Converse would be if conclusion. No? No one? Then hypothesis. I'm not writing the answer. Don't write this in a blank. I'm just reminding you what a converse is. Converse, reverse. Converse, reverse. You reverse the hypothesis and the conclusion. If conclusion, then hypothesis. Inverse. What do you do with an inverse?
You're gonna flip the
Nope.
Make them negative.
Negate. Not. Negate. If not the hypothesis, then not the conclusion. You need to memorize these at home. Lastly, contrapositive. Switch and negate. Reverse and negate. So if not the conclusion, then not the hypothesis. Yes. Leslie. Counterexample ones. If a number is divisible by 5, then it is an odd number. On the test, you better find the hypothesis and put a check, and find the conclusion, put a big fat X. Prove it wrong. So I need a number that's divisible by 5. Let's try 15 first. I want to be wrong first on purpose. Let's try 15. Is that an odd number? Yes. So, ooh, it's not a good counterexample. Try again. Okay, 10. 10 makes the hypothesis true. It's divisible by 5, but it's not odd. So I made the beginning true and the end false, and that is when you have a perfect counterexample. So 10, 20, 30, on and on. Those are all good counterexamples. First part right, second part wrong.
27.
Okay, 27. Did we already go over 27? I don't think we did, but I'll go over it anyway. I don't think we did. How many points does it take to make a unique line? It takes 2. It takes 2 points. So once I add 2 points from the line, I've got the whole line. Once I add 2 points from a line, I have the whole line. You can't pass through 2 points and then not pass through the rest of the line. It's not possible. So if this plane has captured P and Q, that plane has the entire line. So that one is it possible? No. Bad. False. It's not possible. If I have 2 points from a line, I have the whole line. Now, I could get just P. Look at that. Here's P, here's Q. I could get just P and not have the whole line. I've got P, I don't have the whole line. But to get P and Q, to capture this one and this one, I have to capture the whole line. Okay. We're wrapping up. We're almost done. Gone over a lot of it. Number 9, A, E, and C, G. We need a picture. We can't determine if they're coplanar without a picture, so we highlight it and highlight it. Okay. Give me a vocab word for those segments or lines.
Parallel.
Parallel, because you asked me at the beginning. Those are parallel lines. Go to your vocab sheet and look what it says about parallel lines. Coplanar lines that never intersect. Lines that are in the same plane that never intersect. So by definition, this is true. But if you didn't memorize the definition and you're sitting at the test, you just need to look and see, could I put a flat surface through those without bending? Yes, I could. It's a plane shooting diagonally through the prism. So that's a nice, pretty plane. It goes on forever. It doesn't have edges. But I captured both of those lines without having to bend. Yes? What do you mean either way? Yeah, if they're parallel. If I find 2 lines that are parallel, it doesn't matter which way they're going. They are coplanar. Let me show you a time, because I think part of the time y'all think I'm like magical and I can draw a plane through anything, because you're like, I didn't see that plane, and then Miss Tanton just drew one through it, and I didn't know that plane was there. But I'm not magical. There are lines I can't draw a plane through. Like that. There we go. So what about D, H, and E, F? Are those coplanar? I could try as hard as I can, but I could not possibly put a rectangle that represents a plane and capture both of those. I couldn't do it. Why? What vocab word are those? Those are skew. So I can't put a plane from them, so they're not coplanar. I can try, but oh, this plane is in front of that one. DH is behind. I just can't capture both of them. I can't do it. So you can't always draw a plane through everything. Yes. 19. That is a perfect way to rephrase postulate number 4. That is postulate number 4. Since it's a postulate, it's true. It's the tripod postulate. 3 points, not all in a row, determine a plane. So that one's true because it's one of our 4 postulates. Sounds fancy when you talk about postulates. Walk around talking about, well, in this geometry postulate, blah, blah, blah. Sounds really fancy and smart. Yes? Yes, you can like RQP is a representation of a plane. Knowing that this plane goes on forever this way, this way, this way, but we just can't draw that on a flat piece of paper, but that goes on forever. These little segments are representing where the planes are crossing, but the plane doesn't stop there. It keeps going, but we see these segments because planes are intersecting each other, and that's where those segments come from. So yes, that represents a plane, but no, it doesn't have 3 edges. Okay, good question. Okay, guys. I think we're good. I think we've